Hello, I'm Neeraj. Today I will explain the concept of policy optimized dynamic RAG system. When we use the traditional or graph style one pass flow, we generally face at least three different types of problems. First is like we do not get the chance for explicit refinement, verifications, and learning. Why this happens? Generally, in such systems, we take the user query, identify our source documents, or whatever the source of information. In the case of general RAG, we get the vector. If we are using graph RAG, then we extract the graph path or communities which contains evidences related to our answer. Then we combine with the context and then pass it through the LLM and generate the answer. So why we are getting the explicit refinement related issues? Because at the time of output, if we identify that we missed some of the important information in getting the answer. For example, suppose we wanted to retrieve some information related to 2026, but by mistake the system selected got the similarity with the document 2025 and provided the answer. Those informations may be not useful for us and we cannot refine it due to one pass flow. Second is verification. So verifications means suppose our query contains some information about some fact 1, fact 2, fact 3. We do not have any system to properly verify and enforce the system to attach or include every such kind of facts in answers. And third is learning. So we cannot use the feedback whether the answers are correct or not, or it requires some particular refinement in some directions. So we cannot do this. That's why it faces three types of problems. Now, what are the solutions? So one solutions are like a dynamic RAG. So the one of the most famous is self-RAG. Self-RAG is a reinforcement learning based system. So how it works? Till here it will be same. After that it will apply a set of critics. Those critics will contain a set of questions like whether the answers are correct, all the component discussed in the questions matches or not, whether answers satisfies all the guardrails, it violating or not violating any security policies. So lot of such kind of questions will be there. So based on the response of those questions, if it passes majority of the questions, answers for majority of the questions, it will generate the final answer and update the reward. And if it is not, then again the process start from step 2 and it will continue. And it will depends like how many loops you want to continue to get the answers. So this is called self-RAG system. But here we are presenting some different style solutions, which is better if you have heterogeneous type of documents. Like suppose you have a PDF also, Excel sheet also, you have knowledge graph also, and you have multiple different types of documents. Now, how this kind of system is working? So suppose user asks some query, then the queries will go to the state memory. So it is actually a pipeline. So the state memory will contain at least two different kind of documents. First is all types of data, that is called data pod, policy optimized dynamic. And second is all kinds of knowledge, that is called knowledge pod. So this is called evidences, and after evidences it will contain user query. It will again contain partial answers. Now the main process starts here. It will go to the policy controller, that is the main brain of this system. So policy controller's task is, first it will selects the course retrieval policy. So it will check that whether our knowledge pod and data pod contains right set of documents or not. If it contains, suppose it contains the right set of documents, it will identify inside the data pod and knowledge pod, it will extract few text or few paths from knowledge graph, few records from Excel sheet, which are more relevant to answer our query. That number few will depends upon how many, what is the value of your k, 5, 10, 15. It will depends upon that. And after that, it will go to verify the evidence. So how it will verify? It will check that it contains all the informations correctly or not. It says that okay, these things are there, means answer what kind of things you want. So you want informations like suppose fact 1, fact 2 at a particular year, it will check. And then if it gets some threshold value like you have said, then it will say that grounded, another check. And if this check says that it contains sufficient means quality, then okay, the system will go here, write the final answer, and then write a set of rewards. Rewards say it will store three types of values. First is faithfulness. Faithfulness means whether the relevant documents you selected to answer these questions are correct or not. How much faithful it was. Relevance. Relevance means what you wanted or what you asked in the questions, is your answer contains all those things or not. Based on that you will calculate the score. And third is efficiency. Efficiency is very important because this represents the cost. Like what is the cost of this answer? How many times you repeated your repeated your loop to get this answer. So if the loop is high, then efficiency will be low. Now suppose what happens at the grounded enough to answer, means it finds that answer is not so good according to the quality. Then what will happen? There are two scenarios. First scenario is that if you have a sufficient balance of, like your budget is like you can continue with few more loops, then it will refine or rewrite query. For example, suppose you have a fact 1, fact 2, fact 3. You want fact 1 for 2023 but fact 2 from 2026. So based on that it will add the give the that much emphasis on those kind of facts and rewrite the query, and then it will again send those to course retrieval to check that whether we have a right set of documents, whether we have a refined set of documents, whether we have verified all the evidences, and then send here and then return the final answers. But again you face that your system is not giving good result, then you will come here, and here you will check that whether we have a budget to continue more such kind of loop or not. If not, then we will check that how best answer we can retrieve with what we have and give the answer. So this is the process. Now you have understand that how it is different from self-RAG also. Here everything is controlled by a complete pipeline, but in self-RAG everything is controlled by critics on the answers. Now let us try to discuss everything with an example. Suppose you have a travel policy documents. Generally, when you work with for some company and go to for a travel by using company fund or money, they apply some travel policy. So example, we have suppose 8 document related to travel policy D1 to D8. The document D1 is a travel policy related to 2025, D2 expense FAQ, D3 is the same travel policy but 2023. D4 is booking guide, procurement policy, intern handbook, security policy, finance quick card. So such kind of policies generally company maintains in the documented format. Now you have developed a RAG system which can answer all the queries of the user. So suppose user asks the question like what is the domestic per dime and receipt threshold in the 2025 travel policy. The static retriever will just identify the top K embedding similarity. So it identified that okay D3, D4 and D2 like D2, D3 and D4 contains the sufficient informations to answer these questions, and then they passes it to a just LLM, and the LLM gives the answers. Receipt means receipt will require if you spend more than $20 per day, but the data is pulled from 2023 policy and this is wrong. Why this happens? Because if you read the question statement, you find that it is like a 2025 travel policy, but all the documents are like a travel policy 2025. So it gives more emphasis on travel policy, not travel policy 2025. So such kind of issues happen, generally happens. Why happens? So static retrieval just checks the high similarity and then relevant context and no query refinement, because here we don't have a query refinement policy that okay 2025 is not emphasized. So and again there is a no verification phase also, like we discussed. This is a problem with static RAG system, and no feedback system also which can correct through learning process. So generally we get wrong answer. Sometimes it happens. Now come to the scenario like how PODRAG will solve this problem. So again we have the same set of 8 documents and same query that what is the domestic per dime and receipt threshold in 2025 travel policy. We have a state, so state will contain knowledge pod, data pod, and then query, and then partial answers. So 3 things will be there in the state. Now the policy will be applied. So what policy will do? First it will apply the course search. It will check that whether we have a correct set of documents, correct set of knowledge, correct set of documents. So it will check that whether we have a whether we selected these. Then it will find and select, and then it will apply some find selections. It will try to identify the appropriate lines which contains the answers which may be useful for to answer the questions from each of the documents. And suppose here the answer is still old answer like a $40 per day, like by mistake it again selected this, and $20. If your expense is more than $20, then you have to report it with evidence, and it gives here. Then verification phase identified okay the year is 2025 is not cached properly, checked properly. Then it will say that okay refine it. So refinement process will rewrite the query that okay 2025 like travel policy 2025, so that we can give more emphasis 2025, so that the system will exactly search the documents from here. Now the again coarse grain search. So in the coarse grain, this time the system will search document D1, this one, and this one. D2 and C4. It will discard D3 and then find selection. Then it will again pick, then it identify that okay, it is $50 per day, and if you spend more than $25, then receipt will be required. Then it comes here, it verifies everything fulfills, it reports the reward that faithfulness means all the documents evidences are correct, relevance we get what we wanted, efficiency we got it in second, so we can convert it into some score between 0 to 1, and based on that we get pass this to reward model, and at the same time we pass this information to another check. It will check that if the answers are correct, it will display the answer, and if it is not correct, it will go to the another state. This state will say that okay, what is your budget, and if the budget is not, we don't have budget, then with this system will try to generate the answers from the best possible resources that they have this time now. But if this has a budget, it will send the entire system here, and then again the loop will start. And similarly, the reward model will use the reward to continue the learning. So the learning process will learn like what is the uh, means highly rewarded path to get the answers. So they will identify all the paths which having high reward in the learning process. So this is the process, the way the policy optimized dynamic RAG system is actually working.